Okay. All right, welcome everybody. Title of this is Architecting Your Business for Big Data. I'm Bob Stackowiak. I run a team of information architecture and big data specialists that work throughout North America, US and Canada at Oracle. And I'll tell you a little bit about what we do as we go through this presentation as well. I'm always curious about the audience. So any line of business people here? Nope, I was kind of expecting that. Architects? Okay. IT specialists? Most of you probably. Anybody doing any Hadoop projects here? No one. Okay. So you will learn in this session what constitutes big data, where Hadoop and NoSQL databases typically fit in the picture, what organizations are doing with it today, and maybe give you some ideas in terms of how you might proceed on these kinds of projects. Anything that you ask me in terms of Oracle futures is subject to change. Our lawyers make us show that. Let's start with the topic of big data in general. And this is actually a chart I captured from Google Trends about a month ago. And the gold line up there is data warehousing and the number of times that it's appearing in publications and the media and such. The red line is big data, and the blue line is Internet of Things. And so what we have seen over the past 2.5, 3 years or so is tremendous hype as well as confusion about what big data is, and a tremendous number of articles, events, you name it, around that topic. Internet of Things now is starting to follow a similar curve, and they're not disconnected because a lot of the use cases that organizations are going to have for Hadoop clusters and other big data solutions will be driven by Internet of Things. So we'll talk a little bit about that here as well. As I mentioned, I've got a team of folks that work in commercial companies as well as in the public sector, so federal, state, and local, helping to facilitate a series of workshops that we do. What we saw is that companies that were being successful in adopting next generation business intelligence, you can come in, next generation predictive analytics, business intelligence, data warehousing, Hadoop clusters, NoSQL databases, had a similar process as far as how and why they were being successful. And that process usually starts with some sort of a vision. Generally, it's a joint vision shared by IT and the lines of business, looking at it slightly differently. And then what we saw is that organizations that were being unsuccessful kind of jumped to creating a technical information architecture after that step. Oftentimes in this space, the Hadoop space, they were going out and hiring data scientists who were munging through data, not sure exactly what they were looking for, and hence they weren't finding a whole lot. And so, if you follow Gartner Group and some of the analysts now, they're saying we're reaching the trough of disillusionment with big data and such. Well, the reason is because a lot of organizations aren't going about this in the right way. It's very similar, and I'm old enough here, a lot of you aren't. It's very similar to what happened with early data warehousing, where there was a belief that if you simply gathered a whole bunch of data together, business people would figure out how to use it. And those led to some of the most dismal and spectacular failures in data warehousing. So we're starting to see a similar trend in some of the Hadoop implementations at organizations. Now, those that are being successful usually actually go through a step where the business people provide information about how they're going to use the data. Things like critical success factors, key performance indicators they need to run the business. Maybe they take different perspectives on that information. And there's probably some sort of prioritization exercise because they have a whole laundry list of things that they actually want to do. That's usually followed by some sort of a business information mapping exercise or data flow diagrams, if you will, but identifying if these are the key performance indicators we need to deliver, either through dashboards or predictive analytics, where are we going to get the data from? Does the data live today in structured data sources, relational databases? Is it in social media? Is it streaming data? And that then drives the technical information architecture that follows. So form follows function here, just like in other forms of architecture. What comes next generally then is some sort of a roadmap to implementation. So it basically says, here's the business case, here's the priorities, here's how we're going to roll out the technology, here is what we expect to have happen at different points along the way. And then off you all go to some sort of an implementation, either yourselves or with a partner, a systems integrator. And about the time you get done with the first implementation, people have already developed yet another vision. And so you just continually loop through this process. So does that make sense in terms of the process? So what we're actually doing is we're helping organizations through the things that are circled there in terms of developing all of that. Some of them we only engage at early stages, others we're engaging throughout the process really and helping them formulate that direction. Now within state and local government, we've seen some general trends develop as far as what usually are said to be the reasons to do big data projects. These are generally higher level reasons that come from the IT folks we talk to. It's difficult to get real business cases at this level, whereas when we actually go to the business, and I apologize for the size, but there's a lot of stuff to talk about on these. There's some very specific things they're trying to get done. So within Oracle, I always have the discussion around public sector that, you guys aren't one market, you guys do a whole bunch of different things in different agencies, and so the use cases vary quite a bit by the agencies. But around logistics management, we see that these kinds of functional areas that get addressed around things like managing warehouses and supplies, the transportation networks, the route optimization of equipment and personnel, the maintenance that goes on, that's typically being done in places like departments of transportation, folks who are also involved in natural resources, sending equipment, firefighting kinds of activities, as well as law enforcement. So understanding where to put law enforcement based on information that's gathered not only from traditional sources but from social media is one of the applications we're seeing that's growing in this space. Now similarly, on the healthcare side of things, there's some very distinct areas that are being addressed here today. The fraud and abuse management piece of this, the linkage into healthcare exchanges and analyzing that information. We've been involved with a project at the state of Minnesota. Optimization certainly and operational excellence, and then even some marketing activities. And then the third one that I'll present is around higher ed. So understanding trends in terms of students, including whether or not the instruction is really effective, whether or not students are being retained, which students are at risk. The notion, for example, that you might put sensors onto a campus and through their IDs, understanding how much time they spend in the library, how much time they spend at the local bar on campus, if you have such things, those sorts of things, to start to understand what sort of retention you're going to have. And then also from an instructional standpoint, trying to understand the quality of instruction as well. And certainly there's some postgraduate things here like alumni contributions and such, but net is that there's a lot of potential here as well. So as we look at an organization, we generally try to understand where they are in terms of maturity as an organization when it comes to analytics and data. And at this point, I'm not talking about Hadoop. I'm just talking about business intelligence and analytics in general. But what we see a lot of agencies struggle with is this problem of lots of independent data silos that have grown up, either data marts or spreadsheets, whether or not there is a tight IT and line of business partnership such that lines of business trust the IT organization to start pulling this data together, develop single versions of the truth. And then moving on to the more advanced stuff like the predictive analytics, sensor data as in Internet of Things, social, all of that sort of stuff. So a lot of organizations we talk to that are attracted by the buzz of big data still have some fundamental things to solve there on the left that are actually the low-hanging fruit for business return. If you actually pull this information together in a very interesting way, you sometimes start to look at information as a platform and providing that information that you've presented in reports, dashboards, through predictive analytics, all the rest of it, to constituents, to businesses, providing them with information. So giving them another source of data, if you will. Now, the U.S. government has actually done quite a bit of work here, interestingly enough, around data.gov. Where they've established a repository of publicly available data across utility information, natural resources, healthcare, all that sort of stuff. And quite honestly, we and a lot of the other vendors use it to develop test cases and do interesting demos and things like that. But it's a good source of information if you're starting to develop projects like this. What we see happening is that we are now moving into what we're calling a fourth generation data architecture. First generation was mainframe, second generation was client server, third was the internet, fourth is big data in the cloud. And specifically around big data, we're seeing this divide indicated by the red line that separates execution from rapid innovation. So a lot of the work that's done here happens initially in a discovery lab in an R&D kind of a scenario, and that's great. The challenge is that the people who are doing R&D oftentimes don't understand all the things that you need from a data management standpoint. Things like availability, things like manageability, networking, a whole host of things. And so a lot of organizations do have difficulty as they try to transition from purely innovation into the mainstream. Now, what actually happens is just about everyone we talk to has some variation of this today, where they have transactional systems, their HR systems, other systems that are gathering information and reporting on it, And they've got some sort of data warehouses or data marts where they're doing basic reporting, business intelligence, those sorts of things. In some cases, they are doing some predictive analytics there. And like I said earlier, many of them struggle with trying to make the data marts dependent on an enterprise data warehouse versus a lot of people going off and doing their own thing. So that's a challenge. And a lot of the challenges here are political and perception as well as technical that you deal with. More recently, as the need for this innovation engine started to appear, vendors and even and the companies we're working with and agencies have started talking about information discovery engines, a place where you can rapidly explore the data. Usually it's a schemaless kind of a data store where you throw a bunch of data in there. It's self-indexing. Business users start to explore the data, generate some quick reports, maybe even feed the requirements back to IT as far as what they want to see eventually in the data warehouse and through the BI tools. So that's a growing area. For a while, IT organizations tried to put sandboxes into data warehouses. That didn't work because it wasn't flexible enough. The platform tended to be very expensive. There were lots of reasons for that. So the information discovery tools usually look something like this, where you've got the ability to pull a bunch of data in, ask new questions, put together different combinations of structured data or semi-structured data, or both, and generate outputs like you see there. And one of the states that we work with that we saw doing this was state of Pennsylvania, their Department of Public Welfare. They had a lot of questions that they couldn't get answered out of their operational systems and their data warehouses. They were seeing different changing things occurring that by the time IT actually added those in, things had moved on. Some of this was fraud and abuse detection kinds of things. So they wanted to very rapidly have the flexibility to incorporate other data into the mix. So they went down the route of an information discovery tool to start building out a solution like that. As it relates to Hadoop, Hadoop has traditionally entered the picture where organizations are starting to deal with streaming data sources. What you see over there on the left is a weblog, but data that comes out of sensors is very similar. Various indicators, data value, and a bunch of other miscellaneous stuff. This is not a rows and columns problem, so it doesn't lend itself to relational databases. And the early Hadoop implementations were specifically to address data that looks like this. It's originally developed by Google with MapReduce and Doug Cutting, who's now over at Cloudera, with the Hadoop technology for the data store. And what's happened over time is that the role for the Hadoop clusters has actually changed a bit to be not only a repository for this kind of information, but also to incorporate other data as well, including data from relational sources. I'll talk a little bit about why in just a moment. So usually what happens in most organizations is that the Hadoop clusters suddenly appear, and when we're talking to different agencies and companies, sometimes we'll go in and we'll talk to the IT guys, we'll ask them if they have Hadoop, and they'll say, well, I don't think so, but I'll get back to you. And then a person shows up at the next meeting who's never met the rest of the IT organization, who's a recent college graduate, has a statistics and programming background, and is working out in the line of business. And they're deploying something that looks like this, a Hadoop distributed file system, maybe data being fed from a website or social media feeds or sensors. Maybe they're front-ending it with NoSQL databases because they have huge amounts of data that they're going to ingest into Hadoop, which was a standard way of doing that until recently when Hadoop got its own publish and subscribe mechanism. So that's how it typically appears. If they start to find value in that data that they can articulate, usually with the help of a business person, by the way. Organizations that have been successful at this have typically paired the data scientist with somebody in the line of business. And they work as a team. And the line of business person says, well, that's kind of interesting. I can actually use that information. Why don't you incorporate some of this other data in here as well? If they work as a team, that has a tendency to be way more successful. So after they start to find value in that, then generally the business folks want to start to combine information that they've gathered in the Hadoop cluster with what's already in the data warehouse, where they've got transactional information. So show me this citizen that bought these licenses in our transactional system and what their opinion is of our agency and how often they visited a certain facility where there are sensors perhaps detecting them. So those kinds of questions then cause you to actually tie together the entire infrastructure. And you may start to flow data into the data warehouse, or some of the data might end up back in the Hadoop cluster that is in the data warehouse. Now, what this also pictures is that increasingly we're seeing that because of the scalability of this, organizations are starting to evaluate moving their ETL processing from here to using the Hadoop cluster as a transformation engine and then loading the data warehouse through it. That's more of a pure IT kind of use case around the Hadoop clusters. They also see this as a very interesting place to do predictive analytics. Most of them used to do it at the data warehouse. This, if you're also loading the structured data, has all of the data. It may or may not be of high quality, probably not. It's got a bunch of junk mixed in. But if you're doing statistical analysis, the junk disappears in the noise. And this is a flat schema, which is ideal for running things like R or SAS. If you ask the SAS Institute guys where they're going with their most advanced analytics, they've moved their development efforts off of relational and onto Hadoop clusters, because that's where they see the future for how people are actually going to use this stuff. So, good place to do predictive, good place to do transformations. The data warehouse still typically remains a historic source of truth. It's where all the cleansed stuff ends up. And you reformulate the data into rows and columns and make it easy to explore for the casual users who are using business intelligence tools. So it's not an either or, it's really using the right engine to solve a specific set of problems and then linking all this stuff together. Now, as I mentioned earlier, usually what we do as part of that determination is figure out where the data sources are. City of New York actually talked about this at a Strata conference a few years ago. And for them, it was about figuring out which properties were likely to have massive and dangerous fires based on key indicators around when the building was actually built, the property, other things around, somewhat around the income levels of the area, other characteristics of the buildings as well, whether there were tax liens against the building, you know, who actually owned it, those sorts of things. And so that's how they determined their sources. Then they figured out what the output needed to be and what they needed to do in between. Now, there's some problems that you likely have for which the architecture won't deliver the results soon enough. And this architecture, by the way, and blueprint has appeared time and time and time again across a whole swath of industries and agencies. But if you look at today what an Amazon, a Facebook, a LinkedIn has to deal with, their architecture looks very much like this. So does Netflix's, for that matter. I was talking to them a few weeks ago. But they've got a problem where they want, as you're on their website, to recommend other people you might want to know or other products you might want to buy. So how do they do that in real time when we're talking about all this data movement and latency and all of that stuff? What they're doing is they're running predictive analytics in their warehouses and their Hadoop clusters, and about 3 or 4 times a day, they send updates to what they call a real-time recommendation engine. It's an engine that's self-learning and gets more accurate over time. To you, it's real-time because you get a recommendation right away. You're sending your location and user profile information unbeknownst to you, and back comes the recommendations. Obviously, it gets more accurate over time. That's one aspect of real time. Another aspect is, say you're doing traffic management and you've got a bunch of sensors. You want to analyze what's causing traffic tie-ups and such. Well, that's the rest of the infrastructure. But you also want to do some intelligent stuff, like you want to turn traffic signals to green longer in a certain direction to alleviate the traffic problem. Well, then you can actually build some rules and put in an event processing engine. So as the data is captured here, you actually send instructions back to the intelligent sensors and controls on the devices to do that sort of thing. And then you do the analysis over time that we just described. Okay? Of course, we've got products that do all that. But what I will say is that we haven't had a customer implement our entire footprint of all this stuff you see. Most companies have investments in existing technologies, and it becomes a mix and match kind of thing in terms of how they go about it. So they do an evaluation of what works, what doesn't work, what's strategic to the future, and then they start to figure out what pieces they need to actually deliver this sort of stuff. And one of the things I'll say, you know, from a strategy standpoint that we're doing is that we created what we call engineered systems a few years ago that are very optimized around specific workloads here. We've got a partnership with Cloudera Hadoop here. And we've started to do some more advanced things like provide a SQL connection that takes the Hadoop catalog, puts it on the warehouse, determines which data is actually living out here, and then through a high-speed interconnect, sends results back to the data warehouse. And so somebody can generate generic SQL against an Oracle data warehouse and Exadata, and they can use much cheaper storage on the Hadoop cluster to store some of that data and pull it back. So you're starting to see some of the collapsing of these individual piece parts and starting to see the use cases morph into even more useful kinds of scenarios here. One organization that's actually doing a lot of this today with a lot of our stuff is the Washington Suburban Sanitary Commission. And they specifically are doing predictive analytics on their water network health. And they also wanted to analyze social media to understand what their constituents, if you will, their customers, felt was the delivery of service and such. So the stuff is starting to appear, and it's being used in a lot of interesting ways. We had a discussion earlier today about agriculture, and that kind of takes us to the Internet of Things. So let me just hold on that for a minute. One of the things that we are seeing is that whether or not you have a real project as it relates to Hadoop, and a lot of the IT people we talk to want to do things with Hadoop because it's perceived as very favorable for your resume and future individual development. But whether or not you're ready has a lot to do with all the skills that you see there on the left. Some of them are traditional. There's a lot of data integration skills that are required in these kinds of projects. Data security remains extremely important. Used to be that Hadoop was way short on security, but now you can do things like encrypt data in the clusters and encrypt data over the wire, set up Kerberos for security, all those sorts of things. So you just have to be aware of that. You have to be aware of the availability, capabilities or non-capabilities in Hadoop clusters. Basically, you triple replicate data today. So having those sorts of skills is extremely useful. But you also have to have people on the business side that care about data and managing by fact. I always thought the Moneyball movie was right on, and you guys are probably sick of hearing about that from an analytics standpoint. But, you know, a lot of what they were talking about in that movie was getting adoption of doing things differently and managing based on statistics and making decisions based on that versus intuition. So, you know, if you're dealing with an agency where it's still intuition and that's how decisions are made, good luck. This is about the value of data. And what's going on in the commercial world today is very interesting because there's a growing awareness that they that have the data are going to win. And you're seeing different commercial companies getting involved in non-traditional businesses. There are a lot of people afraid of, well, Progressive was mentioned this morning. Progressive and the other auto insurance companies are trying to figure out if they're even going to be in that business in 20 years because they know that the automakers actually get the data as well through telematics, and the automakers might decide to go into the car insurance business and simply insure the best people. We talked to healthcare providers that are worried about Apple and Google providing platforms where sensors are reporting healthcare information back into the iCloud and elsewhere. They have businesses where they send nurse practitioners into homes to do that sort of stuff that could disappear. So this sort of awareness is driving a lot of folks to reevaluate how they're going to do things going forward. Now the benefits from our state of Pennsylvania example earlier, I already alluded to some of them. So this was about fraudulent activity. They also began to understand how crummy their data was as they were looking through this stuff. But what they wanted to do was shorten these prototypes to 2 to 4 weeks so that, you know, if they wanted to add additional data values to the mix, that they could rapidly do that to respond to changing conditions. Because a lot of what happens here is that, if anybody that's dealing with this is in the room realizes, organizations and individuals start to figure out how to beat the system after a period of time. And, you know, as it relates to hospitals and such, they'll change how they code things to get approvals, and then, after a while, other folks catch on and then they change it again. So the ability to, rapidly change is some of what this is about. I wanted to give you an idea as to where to find some stuff. Maybe I didn't include the Internet of Things slide in here. But I'll come back to that in a minute. We do have a bunch of industry white papers based on the engagements that we did over the last year or two. We hid the names of the individuals so that you can't really tell who we're talking to. But some of these apply directly to, hopefully, to the agencies that you work in. I was even skeptical of retail, but based on what I heard your lottery folks are doing earlier today, they really operate more like a retail establishment. And they're eventually going to get into areas like understanding the effectiveness of online advertising and promotions, and maybe reallocate budgets and maybe change the mix of, and actually kill some products that aren't working out so well sooner, which is very much how a retailer or a CPG company works in terms of what they're doing. But I encourage you to download www.oracle.com/go-to/EA. So oracle.com/go-to/EA. Okay. So, possible next steps, and I got a little less than 10 minutes left, so we'll have some time for questions. We can certainly do workshops with agencies if we can get the right people in the room. That's kind of our qualifier. Kind of tells us that, you guys are serious about doing projects. We have Oracle Enterprise Architects, some of whom are in the room, that can facilitate workshops like that. And we also assist in those. And we also just recently published a book that describes a process that I went through that just became available. Now, as it relates to the sensor stuff and the Internet of Things, if you think this was hard, when you introduce the sensors and such, you have to make some decisions about what pieces of this you're going to rely on other folks to provide and what pieces you're going to do yourself. Because the sensors will require programming on the sensors, usually Java or some other language. Java's most popular right now. They'll require a knowledge of your communications networks, working with a provider probably to uplink that data. They'll require that you take a look at the security of the transmissions and access into the devices, because you don't want somebody else, for example, shutting down a critical device at a plant or something. So it gets even more complex. And most folks like yourselves are working with other partners on that sort of stuff. One of the growing areas actually for this, getting back to the agriculture thing, is that we're seeing more and more high-end farm types of scenarios where sensors are being put into the fields. Oftentimes early on it was the wineries, but now it's extending to a much wider audience, with the notion that they're actually gathering information like precipitation very locally, what sort of fertilizers being put down, et cetera. The folks who are building the large-scale farm implements, the tractors and all that, are now putting extensive sensors into them and also pulling geo data as well to direct them as they're actually plowing so that they don't miss certain areas or that they don't over-fertilize certain areas. So even in agriculture, this is becoming a differentiator in terms of where many are going in the future. So the good news for you all is that you're going to have plenty to do, because data is becoming more important. And those that get there early are going to do extremely well in this area. I'm sure that many in the state are going to be looking to you all to do projects like this. So, 5 minutes left. Questions? They're stunned. Yes?
You caught my attention just, you talked about the information discovery engine where prior attempts were in a sandbox for the warehouses.
Yep.
What was the limitation? I happen to be like in planning and architecting, and I'm hearing sandbox, so that jumped out to me.
They were too.
Questions I should ask? Or?
Yeah, they were too slow to develop because you still had to build a schema, right? And so the business guys were, can I just get this thing? That was one problem. Another was that generally they were being built on a fairly expensive platform, or they were being pulled off, onto a data mart. So then you were building out ETL as well. And they were good for relational data, but now you're starting to see a lot of other data types and such emerge. So these next generation tools, we've got one, there are others out there. Basically what they do is you dump the data in, they index the data every which way, does not have to be rows and columns, can be streaming data, and they present you with drill paths through the data that you can then rapidly generate reports around. So much faster in terms of showing potential business benefit using that sort of a solution. Yep.
Is the Department of Health and Human Services in Pennsylvania, they obviously do those things to find fraud, waste, and so forth. Is that referenceable, and then was there a quantifiable value in that project?
What you saw there is from a public presentation that they gave. I think it came from one of the open world presentations. So that part they're willing to talk about. I'm not sure if they're willing to talk about the specifics as far as the amount of fraud and such, but that part they're willing to discuss, definitely. Yeah. I did a presentation for the state of New Jersey maybe about 4 or 5 months ago, and some of our team that had also worked with Pennsylvania was in the room, and they offered to set up a meeting between the two if needed, so let us know. I can connect the dots. Yep. Other questions? Was that useful? Do you get what big data is and what it isn't? Now you can explain it to other people that think it's either just Hadoop or just NoSQL databases. It really is putting together a solution that maps to a problem and figuring out how all these different pieces fit together. I think the exciting thing is actually around the predictive stuff. Predictive analytics used to be something that we would go talk to an organization, and there would be like 10 people in the back room that have been doing it forever, and they hoarded their algorithms and all that sort of stuff. It's becoming widespread in terms of usage, because a lot of organizations are moving beyond simple reporting now, and they want to not only look back in time, but they want to predict what's going to happen in the future. So the skills are getting more and more prevalent, which is, I'm sure, causing additional demands on you all as you hire people in that want to do that sort of stuff. But it's interesting. It's a good time to be doing this. Okay. All right. Thanks.